Hello, this is Mr. Williams, and this is a demonstration for the second part of your GeoGebra assignment for Chapter 1 in Calculus. And so I think we should start off, go to your font size, make it about 20, and you're asked to make some sliders. And so let's make some sliders. You're going to be doing a quartic function. So let's put a quartic function here, slider there for the x coefficient for the x to the fourth power. There's for x to the third power coefficient. The c will be the coefficient for x to the second power. D will be the coefficient for x, and E will be your vertical shift. We're now going to make a function f of x equals a times x raised to the fourth power plus b times x raised to the third power plus, look at my keyboard here, plus c times x raised to the second power plus d times x plus e. And we'll see we have a quartic function. We can move this around, change your coefficients, and obviously expect E to be just a vertical shift. So let's make this a little more so I'm just going to put a slider there. Click over on your arrow, and I'm going to choose a different color. We'll choose green. I'll make it a little bit thicker. There we are. One of the things I asked you to do was to put a point on this function that's movable and that shows the tangent line. I didn't have time to put it quite on the homework check, but another part of this feature is you also need to be able to make it so that it will trace the slope of that tangent line and feed those points into a spreadsheet that we can analyze and find out if we can come up with an equation for the relationship between x and the slope of the tangent line. But I think we'll see how that works. I'm going to put a point on this function. There's the point A, and let's make A fairly prominent, and I'm going to object properties. Let's make the color blue. Let's make it fairly big. And there's the point. Let's put a tangent line through that point. So we're going to go down to our input and say TAN for tangent, and you'll see it gives us a bunch of choices. We're going to choose tangent, and we've got a function, so we'll choose point and function. Our point is point A, and our function is f of x. And boom, we see that we have a tangent line. As I move point A, make sure I'm on the arrow, the select arrow, and I see my tangent line moving around. Looks good. what I'm going to do now, I'm going to make this tangent line a little bit bigger, thicker, I guess. Yes. So there's my tangent line. I want to measure the slope of that tangent line. And if I go through here, I will see that one of them is slope, and I want to measure the slope of this line, and it shows me that. But I don't really want to see that M there all the time. So I come over here, so I click off on it so it's not visible. But it is a variable now that I can move. Matter of fact, as I move my point, go to point A, I'll see over there that when I look over here, M is changing. But I'd like to note that. So I'm going to make a little text box. And I'm going to say the slope of the tangent line to the function at A is, and here's the tricky part. I want to use the objects, and so I have all my sliders, but M is what the slope is. So I put in M, and I say OK. And sure enough, it tells me the slope of the tangent line to the function at A is negative 2.91. As I'm moving that, I see that it's changing. The next thing I'm going to do is I'm actually going to plot a point that will show me the slope. So I'm going to call that point B. I'm going to say point B equals, and I'm going to do a lowercase x parentheses A. What that's really saying is, hey, go look at point A and take whatever the x value is at point A. Wherever A is, go find out what the x value. That's what I'm talking about. And I want you to plot, so right now A is at negative 0.58. So B, it's going to put point B, it's going to put a point at negative 0.58. But I want my y value to be what the slope of that tangent line is. So I'm going to say M. And I hit enter, and I don't see anything. And that is because the slope of the tangent line right now is negative 2.72, and my y values, when I'm going down to negative 2, I really can't see that, but it should pop up here as I move. There's my point B moving around. There it is. Now the slope is very close to 0, so there's point B, positive. So we're kind of seeing what's going on. So what I want to do, I want to make point B a little more prominent. So I'm going to select point B. Oops. I'm going to go to Object Properties. I'm going to make this a larger point, and I'm going to change the color to, let's make it red. There's my point B. So now I can kind of see what's going on. I'm moving along. There's point B. Interesting. So what I'm going to see here is I'd actually like to kind of see what this looks like. So I'm going to click on point B again, go to Object Properties, and I'm going to go to my basic, and I'm actually going to trace this. Click on Trace. Okay, so you can tell it kind of Kind of looks like a cubic function. The graph of the slope of the tangent line looks like a cubic function, which is interesting. And I want to explore that a little bit more. So here's my function. So what I'm going to do is I'm actually going to open up my spreadsheet. Here's my spreadsheet now. I'm going to right click on point B and I'm going to say record to spreadsheet. And I'm going to click on trace to list. Say close. I'm going to move along here, and it's sure recording an awful lot now. Got all kinds of data there. So I've already got 592 points that I've put in there. Actually, a lot of them are the same. So there's the recording. And what I'd like to do now is I'm going to this is pretty fascinating, but I'm going to, on my spreadsheet, I'm going to actually analyze this data now. So I'm going to do 2-variable regression analysis. And actually I should probably select these 2 rows. And so once again I select A and B. I'm going to do 2-variable regression analysis. And I'm going to analyze it. It does look like a cubic, and so let's check out a regression model. It wouldn't be linear, wouldn't be a good fit. Looks like it's going to be a polynomial, and I think it's going to be a cubic is going to be the best fit. Sure enough, that looks like a. Now, one nice thing is you can look at this and see, you know, the quadratic regression was terrible. The linear regression is awful. But look at the when we get to the cubic, it looks like it fits perfectly. And let's see what it came up with. Okay, so it has a really nice fit, and the equation for that is y equals 1.4x cubed minus 4.65x squared plus 2.3x plus 0.45. Looks great. And we'll do a lot more talking about this in class, but I think what you see the power of this is we've got we collected all this data, got a very nice fit, perfect fit. It was a quartic function, but the cubic regression model looks awesome. We see a kind of a picture of what the slope of the tangent line is to a function, and so the quartic function had a cubic, what appears to be a very strong cubic equation that would be the graph of the slope, and there you are. You will save this file and save it as the second part, and this would be and upload it as your assignment. Thank you very much and have an awesome day. Bye.